Michael, what's today's audio topic?
Today we'll review the TEAC UD-701N, which packs a USB DAC, network player, preamp, and headphone amp into one unit.
How would you classify this product?
TEAC's website lists USB DAC first in the UD-701N description, so let's classify it as a digital-to-analog converter.
Got it. Master, you want to hear about TEAC's UD-701N too, right?
Yes, I want to hear.
What's the price for the UD-701N?
For $1,299, it's TEAC's flagship model. It has a substantial presence in full-size audio. Included accessories are a remote control and power cable.
Got it. What are the key features of the UD-701N?
The standout feature of the UD-701N is its original discrete DAC, the TRDD7. By not using existing DAC chips, it achieves TEAC's unique sound.
What exactly is a discrete DAC?
A discrete DAC refers to a DA conversion circuit built entirely from scratch in-house, combining components like resistors and capacitors, rather than using off-the-shelf finished chips.
That must be labor-intensive and costly.
Let me explain discrete DACs further. First, differences from conventional DACs, IC chip method. Most audio equipment uses DAC chips, ICs, manufactured by companies like ESS or Asahi Kasei mounted on a board. The IC chip method condenses all the circuitry into a small square chip. It's inexpensive and high performance, but the sound character is constrained by what the chip manufacturer has defined. In contrast, the discrete method builds the circuit by arranging dozens to hundreds of small components on a board. This allows the manufacturer to pursue their ideal sound by controlling the flow of electricity down to the finest details. Second, how a discrete DAC works. A discrete DAC primarily operates in two steps. Digital processing. The incoming digital signal is processed by a custom-programmed FPGA, field programmable gate array. Here, the manufacturer applies its proprietary filtering to convert the signal into ultra-high precision. Analog conversion. The signal from the FPGA passes through either a precision resistor ladder circuit, R2 or ladder method, or a proprietary delta sigma method, like the one in the UD-701N. By adjusting the timing and amount of electricity flowing through each component, the digital zeros and ones are converted into smooth analog signals.
R2 or ladder method? Delta sigma method?
Trying to explain it in detail just brings up more terms I'd have to explain. Broadly speaking, there are two main methods for converting digital signals to analog signals, the R2 or ladder method and the delta sigma method. First, R2 or ladder method. This is a classic technique that combines two types of resistors, R and 2R, arranged like a ladder. The mechanism involves weighting the signal value before performing direct conversion. Weighting assigns a voltage weight, using resistors for each bit, 1 and 0, of the digital data. Direct conversion means, for example, that 8-bit data instantly generates the corresponding voltage through the on/off state of 8 switches. The advantage of R2 is its extremely simple signal processing. It is said to produce very fast sound transients, resulting in a powerful, tangible sound. The disadvantage is the requirement for extremely high precision in the resistors. Even slight errors directly translate into sound distortion. Achieving high resolution like 24-bit necessitates using high-precision resistors in series, which increases cost. Second, delta sigma method. This method is used in most modern DAC chips and in the discrete DAC of the UD-701N. Its mechanism involves oversampling, pulse density modulation, and noise shaping. Oversampling drastically increases the sampling rate, the speed along the time axis, in exchange for reducing the number of data bits. It switches between 0 and 1 tens of millions of times per second at ultra-high speed, then uses pulse density modulation to create an analog waveform based on the density variations. Noise shaping pushes the noise generated during conversion into the ultra-high frequencies inaudible to the human ear. The advantage of the delta sigma method is that it doesn't rely too heavily on resistor precision and excels at precisely reproducing high dynamic range, from quiet sounds to loud ones, like modern high-resolution audio sources. The disadvantage is that it requires extremely complex calculations, which can generate noise or a calculated sounding quality during the computation process.
I see. So the UD-701N uses the common delta sigma method for DA conversion but incorporates TEAC's proprietary components. I understand discrete DACs can produce a manufacturer's unique sound, but does it sound better than ESS or Asahi Kasei?
That's a crucial point. I previously used Marantz's SACD30N. The SACD30N featured Marantz's discrete DAC, but I didn't find its sound particularly exceptional. But the UD-701N sounds fantastic. So, discrete DACs do have the potential to produce sound qualities not found in existing DAC chips.
I see.
By incorporating TEAC's Delta Sigma discrete DAC, we gain the following benefits. The characteristic digital-sounding quality of off-the-shelf chips is eliminated, resulting in a natural and vibrant sound. Plus, its unique algorithm captures even the finest details of music, like subtle reverberations and a sense of air. To use an analogy, IC chips are like premium retort-packaged curry. They're convenient and highly refined, but you can't fine-tune the flavor. Discrete components, on the other hand, are like a curry made by blending spices with meticulous care. It takes effort and costs more, but it perfectly expresses the chef's ideal flavor.
Michael, that's a great analogy. Now I'm craving curry too. Master, one of your signature discrete curry dishes, please.
No, no, no.
Discrete DACs are essentially the crystallization of a manufacturer's technical prowess. The UD-701N invests heavily in this aspect, which is why it commands a higher price. Now, let's start with the front panel. On the left are two headphone jacks. One is a standard 6.3mm jack, the other is a 4-pin balanced headphone jack. Then there's the output selection button, menu button, USB memory connection port, and a small display that only shows source information and frequency. It has network functionality, but it can't display album artwork. And the volume control. The UD-701N also has a preamp function, so you can adjust the volume. Now for the rear panel. It's a dual mono design with separate left and right channels, so it has distinct RCA and XLR analog outputs for each side. Then there are two coaxial and two optical digital inputs, a LAN port, a USB memory connection port, one USB-B port, and a trigger terminal. Plus, there's a 10 MHz clock input terminal.
Being a serious DAC, it has a wealth of input terminals.
Like the TEAC UD-701 we discussed before, it has those distinctive 3-point support feet. They should be effective for vibration control. Also, the UD-701N has an upconvert function, capable of upconverting input frequencies up to 352.8 kHz. I couldn't tell the difference. TEAC's app was quirky and awkward to use, but using Kubla's Connect or Spotify Connect solves that problem.
The UD-701N is pricey, but it's packed with features and clearly has a strong focus on sound design. How does the UD-701N actually sound?
It sounds quite different from any DAC I've used before. It lacks the sparkle you get from ESS or Asahi Kasei chips, but it's incredibly clear, the kind of sound you could listen to forever. Plus, there's absolutely no perceptible noise. I realized just how impressive TEAC's discrete DAC technology really is.
That was a new discovery.
Discrete DACs are expensive, but I see now they're necessary if a manufacturer wants to achieve their own unique sound signature. Next, let's talk about comparing it to the Shanling SM1.3, which uses Asahi Kasei's flagship DAC chip.
Guys, closing time is approaching.
Already? It's that late? Let's continue next week.
If you enjoyed the video, please subscribe to the channel.